Jesus is so amazing, amazing. Yes, responsible for great things. Jesus is so amazing, amazing.
So let's do a listening check. Alright, this is a listening check. All I want you to do is underline multiplying and dividing. Underline multiplying and dividing. Alright, so this is multiplying and dividing rational expressions. And all rational expressions are just expressions in the form of a fraction. Okay, so when we're looking to multiply and divide and adding and subtracting rational expressions, really what we're doing is we're doing the same thing we would do with fractions if we were just normal numbers. So let's look at an example. Again, it's just an expression in terms of a fraction.
Responsible for great things. How many of y'all know you're responsible for great things?
Okay, so when multiplying, the first step is always going to be to factor everything, and we should be experts at factoring by now. And since we are experts, I'm going to teach you the shortcut now that we know the box method really well. The shortcut is if there's invisible 1 next to the x squared, all you have to do is just ask yourself what multiplies to the last number and adds to the middle. What multiplies to the last number and adds to the middle. So for that reason, I'm not going to do any boxes. So all of this is going to break down into x plus or minus something, x plus or minus something. So what two numbers multiply to 7 and add to negative 8? 7 and 1. And what are the signs? It's going to be negative and negative, because negative 7 times negative 1 is positive 7 and so forth. This one, 9 and 4. And again, look at the signs. What multiplies to positive 36 and adds to negative 13? Okay, so this is the shortcut. It only works if there's no number in front of x squared. 24 and 10, about 6 and 4. Yeah, and then negative, so that it can be multiplied to positive and add to negative 10. 2 and negative 3, about 2 and 1, and both negative, so it can multiply to positive 2 and add to negative 3. So again, this only works if there's no number in front of the x squared. That's the shortcut. So once you've factored everything, just like fractions, you're going to multiply the numerator and multiply the denominator. Okay, so just looking at this, I'm just going to write it all out on the numerator because you're just multiplying it all out. And then same thing with the denominator, just write it all the way across because you're multiplying it out. And then finally, step 3 is going to be to simplify. And again, if you need help with simplification, just turn the page or just see simplifying expressions. This is a listening check. This is a listening check. Go ahead and color in C simplifying expressions only. Just color in any color you want, C simplifying expressions. And all that means is basically whatever's on the top can cancel with whatever's on the bottom, right? Factor. So looking at the top, what do you see that's on the top that is also on the bottom? I see x minus 1 and x minus 4. So those can be cancelled. So that leaves us with on the top x minus 7, x minus 6, and on the bottom x minus 9, x minus 2. And that's your final answer. Now I have seen questions where they ask you what the domain of your function is or your expression is. So domain of rational expressions is all real numbers. Domain of rational expressions is all real numbers except where the denominator is equal to 0. Where the denominator is equal to 0. So again, remember domain is x. So we can have all values for x except where the bottom of the denominator is equal to 0, because remember you can't divide anything by 0, you get an error. So just set the bottom to 0, so x minus 9, x minus 2 is equal to 0. And you've done this before, go ahead and separate it, x minus 9 equals 0 or x minus 2 equals 0. So x equals 9 and x equals 2. So when x equals 9, it's going to make the denominator 0, which you can't have that because you have an error. So the domain is all the values of x except when x is equal to 2 or when x is equal to 9. Okay, so that's all domain is. Alright, let's take a look at dividing rational expressions. And honestly, if you can do multiplication, you can do dividing. There's only one step difference, and I don't know if you remember this from when we did fractions. Alright, so step 1, to divide, you're going to make it multiplication. To divide, you're going to make it multiplication by flipping the second expression. By flipping the second expression. Alright, then number 2, you're going to follow the steps of multiplication. So what we just did, you're going to follow the steps of multiplication. So only 2 steps, because if you can do multiplication, you can do division. Alright, so then let's take a look at an example. So let's say you had 2q squared minus 7q minus 4 over 3q minus 1 divided by q minus 4. Alright, the very first thing you need to do is make it multiplication by flipping the second expression. To flip the second expression, you need to put it over 1, because there has to be something to flip, right? Then you write the first expression out, so just as it is, the first expression out. Then change the division to multiplication, and then flip the second one. So 1 over q minus 4, just like we did when we were multiplying dividing fractions. And that's it. Then follow the steps of multiplication. So this really becomes another example for multiplication. Alright, so it says factor everything completely. So because this one has a 2 in front of the q squared, we can't do that shortcut, which is why I taught you the box method first, because it works for everything. So we'll do the box method because there's a 2 outside. So draw my 2 by 2, first term in the first box, last term in the last box, and then multiply the first and the last term. That's going to be negative 8, and the middle is negative 7. Multiplies negative 8 and adds to negative 7. Negative 8 and 1, positive 1, right. Put those in the 2 remaining boxes with the middle term, which is q. And then what can we take out? We can take out a q, and we can also take out 2. And then 2q times something is 2q squared, so that's q, that's going to be 1, that's going to be negative 4. Check the last box, negative 4, perfect. Alright, so 2q squared minus 7q minus 4 breaks down to that. And then now we go to look at what the next step was on multiplication, was multiply the numerators multiply the denominator. So we're going to put this all over one line because they're just multiplying it out. So times 1 over 3q minus 1 times q minus 4. Alright, then look back at multiplication. What was it? Simplify. Alright, so we're looking at what's on the top and the bottom, q minus 4. Perfect. Anything else? No. Alright, so this is what's left. 2q plus 1 times 1 is 2q plus 1. And then on the bottom, 3q minus 1. And that's it. Alright, so again, let's take a look at domain. What is the domain of this expression? Remember, the domain is all real numbers except when the denominator is 0, because anything divided by 0 is an error. This is a listening check. Put a smiley face anywhere on this page. Put a smiley face on this. Alright, so let's set the bottom equal to 0. So 3q minus 1 equals 0. Take the 1 to the side, it becomes plus 1. It goes away. And then we're going to divide everything by 3. So q equals 1/3. So the domain is all real numbers except when q is equal to 1/3, because when q is equal to 1/3, the bottom is going to be 0, and you know you cannot divide anything by 0, you get an error. And that's it. Okay, so that's all we have to multiply and divide in rational expressions. If you're good with fractions, you're good with this.